for this particular problem, you have water entering a tank at this rate. You have water leaving a tank at these two rates, depending on the time. Here's a picture of these two sets of graphs. Nice for them to give you a picture, so you don't have to really put it in your calculator quite yet. Ooh, they even give you the points here, so you don't have to find them. See the points where they intersect, right here and right here? That's kind of nice. Could you find the points of intersection with the equations given? Yeah, they give it to you. That's very, very nice. It saves you a little bit more time. And the tank started at 5,000 gallons at time 0. So they give you some initial, and we're going 7 hours. Hours. You're going 0 to 7 hours. And if you can tell, these two equations are rates. See right there? Gallons per hour, gallons per hour. So we're starting with two equations that are rates. And you have to, really important to pay attention to that. See, rates, gallons per hour, hour. Anyways, how many gallons of water enter? It's a very important word there. The tank during the interval. Round your answer to the nearest gallon. Also make sure you round. Follow directions. Anywho, so entering, how many gallons? Well, isn't this right here entering? This is entering. F of t is the rate at which it enters. So if I want amount entering, that means it's the integral of f of t. So it's simply going to be from 0 to 7, because it's 7 hours. And what's really nice, you guys, and you should get used to doing this, is just write f of t. They know what that is. Don't forget dt. And that would be the total amount entering from 0 to 7. Now when you do that, you get approximately, when you do it, actually you get approximately, when you round it, you'll get 8,264 gallons. Remember, it's saying amount, so it's gallons. They didn't ask for units, but it's still good to put it when they're having it. So there is the first piece. Pretty simple question for that one, amount entering. Now the number 2, find the time interval, or time intervals, during which the amount of water is decreasing. Give reasons. Reasons are the pain. Now, intervals, amount of water decreasing. Whenever you hear the word amount of water, that's talking, if these are rates, amount is the one before that, the integral of these. So amount is before that, but when I see the word decreasing, that also means derivative negative. So if we're talking about amount, and we're taking the derivative and finding where it's negative, aren't we talking about now the rates of amount? And aren't the rates of amount in these equations? These equations right here are the rates of the amount. So what's kind of nice is we're basically trying to find out the negative values of these functions. Now, what you first got to realize is you have to kind of make a new equation. I'm going to call it h of t. And h of t is going to be 5,000. That's what we start with. Plus the integral from 0 to 7 of what's coming in, which is f of t, minus what's going out, which is d of t, dt. That is the amount. That is the equation for the amount of water in the container. I want to find out when this function is decreasing. Now, instead of making an equation and doing all sorts of junk with it, there's actually an easier way to do this is by looking at the graph. Now, you could graph this. You could, on your calculator, do all this and make a graph of it and use your calculator to do the whole work. But let's focus in on a different route. And what that means is, basically, do we care what we started with to know about decreasing? Does what you start with matter what decreases amount? I mean, the rate at which the amount decreases? No, that has nothing to do with it. So we focus in on this. Okay? And, oh, sorry, this is the amount. Don't we want to know when this amount is decreasing? So when you're saying decreasing, you're saying integrate, derive this. When I derive 5,000, what do you get? 0. When I derive this, don't I just get f of t minus g of t? So isn't h prime t simply f of t minus g of t? So that is actually f prime. So I want to know, when is this function I want to know when h prime t is less than 0. That's my goal. So where is h prime t less than 0? Where is it less than 0? That's my goal. Well, let's look at the graph. F minus g. This is f. Isn't f positive from here to here? So at this point right here, if f is, this is g. G is bigger than f. So for this interval, do you understand, if g is bigger than f, won't it be negative? So when is this? From 0 through, and what's that dot right there? What it says right here, 1.617. From 0 to 1.617, is that less than 0 or greater than 0? Now, for it to be less than 0, wouldn't g of t have to be the bigger number? Looking at this, aren't we looking for decreasing? Aren't we looking for when g of t is bigger? Because if g of t is bigger, isn't that going to be a negative value? So is g of t bigger here? Yeah, g of t is bigger because the derivative is less than 0, so g of t is larger. Where else is g of t larger? Well, isn't f bigger here? And g of t is smaller. But if we go over here, isn't all of a sudden from here to here? Isn't here, is this g right here? Is g bigger than f? So since g is higher than f, for this interval from 3 to this point, isn't that also going to be decreasing? So from 3 to, let's see, that dot says right here is 5.076. So for those two intervals, the derivative is less than 0 because g of t is greater than f of t. The reason? G of t is greater than f of t. That's my reason. On those two intervals, g of t is greater than f of t. Thus, these are my intervals for which it is decreasing.